I'm a Senior Director at PTC. Industry 4.0, or the fourth industrial revolution, has really transformed the way the products are created, manufactured, operated, and serviced. So PTC technologies such as Creo, the CAD solutions, Windchill, PLM solutions, ThingWorx, the industrial innovation platform, and Vuforia, or augmented reality solutions, have really enabled this Industry 4.0 implementation and adoption. So we would like to explain to you how all of these technologies, especially the industrial innovation platform, ThingWorx and Vuforia's augmented reality, work together in a real-time scenario with live demonstration. Let me explain you the setup here. So this is a motor, a small DC motor, similar to an industrial motor that runs in the factory. This motor is retrofitted with 3 sensors. You can see the first sensor here. This is the thermal sensor to measure the temperature. We have another sensor here right behind this cooling unit, which is like a vibration sensor. And then we have one more sensor here, right here, to measure the current. So it has got 3 sensors, temperature, vibration, and the current. It also has a cooling unit here right behind this motor. As the temperature goes up, it gets heated up. To cool it, the cooling unit automatically starts here. So that's the cooling unit. Now this entire setup has this Raspberry Pi, which is used here to transfer the data from sensors to the IoT platform, and the data is getting transferred through the Wi-Fi network. So the scenario here is, once the factory operation starts, as the motor starts running, so we are actually monitoring the temperature, vibration, and the current of the motor. And if the temperature goes beyond certain limits, so automatically initially the cooling unit starts. And if that still doesn't bring down the temperature, and if temperature continues to exceed, then automatically the whole plant shuts down. So that's a scenario that we would like to explain. So let us start the factory operations. Okay, here you see the motor has already started running. Currently everything is fine. The green light is on. So let us go to the control room and monitor these parameters remotely. So this is my control room, and we have a big screen, and you can see the temperature here coming directly from the thermal sensor of the motor. This is the current measurement, and the vibration currently is everything is fine. So as the temperature is going up here, you can also see the trends analysis, so you know exactly how the things are happening. Now the temperature is increasing, it's going into the yellow zone. The moment it goes to yellow zone, that means it has crossed 32 degrees. So my cooling unit has to start. So probably here you can check here, the cooling unit is already started. So its job is to really bring down the temperature now. So but still we'll continue to observe the temperature here at the control room here. The temperature is still not going down here, it is still exceeding. See, the temperature is going above certain limits. And the moment it comes to the red zone, that means the entire plant has to shut down. And the moment it has gone there, you see the entire plant is shut down, and the red alarm button has become on. So that's automatically sends a phone call to the service technician who is not currently present here in the plant, so he's somewhere in the remote. So but because of this temperature increases, so the entire floor has gone, and it has sent the phone call.
Press any key to execute your code.
Oh, I think something urgent.
Attention, motor temperature exceeds threshold. Attention, motor temperature exceeds threshold. Attention, motor temperature exceeds threshold. Attention,
motor temperature has increased the threshold. So the message says the unit has shut down. I think I should rush towards the plant so to understand what exactly has happened, what issue has came up. Now, to understand the issue, so I don't have any idea about what exactly happened, because already event has been executed, so plant is in a shutdown stage. Now with the Vuforia studio, we want to understand what exactly the status and trace on what the issue is. Now to find out what exactly the issue is, just a moment we will scan the ThingWorx, the system open the model target. Now in model target can be we can focus on any component, so it help us to understand any consequences on particular equipment. The moment we'll set the model target, now here you can see this entire statics is visible here. Now fan condition is okay. Motor temperature specification has been mentioned here. If it is okay within the 25 to 30 degree and warning, so 32 degree. Now stop, plant stop if temperature increases 45 more than 40. Right now temperature 47 degree. Now what exactly things are other components status of the control panel is also okay. Now, I want to understand what needs to be action needs to be taken care. The corrective action. These are the corrective action. If we see, like check overload on the motor. So if we want to check the overload on the motor, there are some instruments we can put it and check it whether the overload on the motor is there or not. Another measure I can do is switch on cooling and let reduce the motor temperature. If it reduce for less than 45 degree, motor will and unit will automatically start. But I want to before giving the green signal to run the plant, I want to cross check what other instrument and what other sensors has been put on the equipment which really required to monitor the values and status of the unit. Now here is the Vuforia chalk. The moment to open the Vuforia, I would like to take help from some expert and a backend support. So because I don't have any idea about other equipment, other instrumentation which has been fixed on equipment. Now here I'm calling my expert on the other side. He's remotely located somewhere. No, call. We're giving call to our expert. Hello. Hello. Hi, Dhirendra.
Hello?
Hi, Dhirendra.
Yeah, hi Abjan, how are you?
Yeah, just I reached the plant. Plant has been shut down. So I took some understanding on from the sensors. Temperature has been shoot more than 45 degrees. This is the one reason the plant has been shut down. But I want to investigate some more issues. Cross check that what are the other sensors are working or the instrumentation is in good state or not. So I want your help to understand instrumentation part of that plant where other sensors has been retrofitted, so I can check before giving a go ahead to that plant.
Okay, so what I understand is the plant is shut down because the motor temperature has gone beyond 45 degrees and
Yeah.
the whole plant is down, and right now you are there in the plant to really investigate and do the maintenance, right?
Yeah.
Okay, so the temperature has gone up. That means probably you need to check the thermal sensor. You have any idea where it is fitted?
Yeah, I don't have any idea where it is. That's why I want your help.
Okay, sure. So just focus on, now I can see the motor actually.
Yeah.
Just go a little bit down that panel there. Yeah, exactly. Just hold on for a second. You see here, this particular thing?
Yeah.
What I've highlighted in yellow?
Yes.
So that's the thermal sensor which measures the temperature.
Okay.
So probably you need to relook at that.
Okay.
And at the same time, I also want you to check maybe on the vibration and also the current. The vibration is slightly behind the cooling unit. Can you just focus?
Let me check the sensor. It's in good
yeah,
condition.
yes, that's the.
Yeah, it is okay.
correct,
Yeah,
correct.
it is
That's
in
the
good
thermal
condition.
sensor.
No problem. It is
Yeah.
good condition.
Yeah. Can you go behind the cooling unit where I would also tell you where the vibration sensors are there?
Yeah, I just
Yeah,
behind
yes,
the
that's
cooling
right.
unit.
That's right. Hold on. Now you can see this particular thing.
Yeah.
Yeah, that's the vibration sensor.
Okay.
And also there's one more sensor for measuring the current. You just have to come on the right hand side, this side.
Okay.
Yeah, you have to come this side.
Yeah.
Yeah, yes, just hold on. Yeah, you can see this one, which I just circled. So that's the current sensor. So probably you just need to check amongst these, and hopefully you'll be able to fix the problem.
Yeah, it looks nice. Yeah, it's okay. Okay.
Okay.
I think everything is fine. Okay. Thanks.
Yeah. Okay, all the best. Thank
Yeah.
you.
Thank you. Okay, so I have understanding about where the other sensors are there. I have checked all the sensors, all instrumentation part is okay. Now another area which I am very interested in, I have to send the document back and to give a record. So whatever have been discussed and what sensor has been pointed out and what checks has been done. So there is a recording of all those markups which has been done so far during the communication. So let's check it. So, give the go ahead to the unit, because we have checked that that entire unit, so entire unit in that state. I think if we increase, here it has been mentioned, if motor temperature got reduced less than 45 degree, unit will automatically start. Now I gave the information to my control room, just start that cooling unit, let temperature goes down. Now here we can see, if I show you, now here you can see the cooling unit has been started. Now temperature start going down. Here you can see on dashboard the temperature start going down. Now the moment it goes down, here the graphical representation shows the trends. It also goes down. The moment it goes down less than 45 degree, my motor will automatically start. Right now it is not in a running conditions, so just we are waiting for that. Yeah, temperature goes down, so unit has already started. Here we can see it is in warning zone for the fan is inside. It has been reduced. Now we can see the temperature further goes down. Now when you're talking about such kind of the setups and the real-time scenarios, we can take a business value from it, the optimum utilization of the resources. The resources will run as and when required. So cooling unit will run till the temperature goes down less than 32 degrees, because we have mentioned in the green zone. The moment it reaches that particular location, cooling unit will automatically stop. Cooling unit will automatically stop. So that's we are providing a value proposition. You can imagine, so how many unit can be optimized and it can be used optimally to give the more benefit and all. Here it goes down, further it is going down. The moment it reaches here. Now here we can see it's going down, so let's have a view. So the moment it goes down, our cooling unit automatically stops. It goes down, our cooling unit is going to stop. Now automatically signal has been triggered to stop its cooling unit.
So let me summarize it for you. So we just saw how a remote monitoring of the smart and connected product can really help reduce or eliminate a costly error that might happen in the factory because of not continuous monitoring personally by certain technicians at the plant. So the sensors, connectivity, IoT platform, augmented reality, all of these coming together to really provide this kind of technology which will enable the remote monitoring of these motors with the condition-based monitoring, and providing the alerts, providing the notification at the right time, so that we take a right predictive maintenance approach. So thank you very much. I hope you got the conceptual idea of this IoT and augmented reality. Thank you very much.